Hello everyone. Today let's start to understand Snowflake database. Basically, Snowflake is an advanced database platform which is provided on the cloud as a software as a service. Snowflake provides data storage, query processing, and various analytical solutions that are faster, easier to use, and it's having a much more additional features that traditional data platform does not provide. The Snowflake data platform is not built on any existing database technology like big data, Hadoop. So instead, Snowflake innovates completely new SQL query engine specifically designed for the cloud. Snowflake is a purely SSAS as a software as a service where we do not require to select any software to install, configure, and manage that as well. Also, we need not to worry about ongoing maintenance, management, and upgradation of the software. That everything is handled by the Snowflake. So let's start about talking about the architecture of the Snowflake. We have three main components. One is a database storage, second query processing, and the cloud service. So here you can see in the database we have a different storage that has been provided by the cloud services. Second is a query processing where we have a different multiple virtual warehouses that is used for the query processing and managing the query. And the last one is a cloud that is that component actually works for the providing different services called as like authentication and access controlling, then infrastructure management, and the query optimization. Then it saves the metadata and also provides the security to the Snowflake database. So let's start about going in details about the each three components. So the first one is the database storage. The main work of the database storage is to reorganize the data into the internal, optimized, compressed, and columnar format. So basically, the Snowflake has the database storage which is provided by the cloud, and the database storage, the data has been stored into the database storage in a different format. And usually, any other traditional database we stored the data in a different format, but in Snowflake we store the data. Snowflake stores the data in a columnar format. And also, while storing the data, the Snowflake automatically reorganize that data so that the query processing and the retrieval of the data would be faster as compared to traditional database. Also, Snowflake manages the organization of the data, then file size, then structure, and the compression technologies it uses. Also, it consumes the metadata and the statistics of the data. The data objects that has been used in the database storage is not directly accessible to the client or the customer. It could be accessible via the SQL queries only. So that is all about the database storage. Second is the query processing. So the query processing, we simply call it as a heart of the Snowflake, where we actually manages the different virtual warehouses. Basically, this virtual warehouses is the MPP compute cluster composed of the multiple compute nodes allocated by the Snowflake to process the query. It optimizes the query, it processes the query, and it retrieves the data as much as faster as compared to traditional database. So each warehouse has its own compute resources. Those compute resources will not be shared with any other warehouses in the Snowflake, so that each warehouse works independently. Every virtual warehouse does not impact to other virtual warehouse while processing the query. So third would be the cloud service. Cloud service is we called it as a brain of the Snowflake, where cloud services provides the multiple services as we talked about. Like it provides the authentication, then infrastructure management, then metadata management. Also, it provides the query parsing and the optimization of the query. Also, it provides the access control. So this is all about the architecture and its component. In a fourth slide, we will see that the warehouse sizes. As we talked about the warehouses, virtual warehouses that we have to create in the query processing part, Snowflake provides the privileges to select the virtual warehouses sizes as per our query processing load and the data sizes. So Snowflake provides the different sizes of the virtual warehouses. It starts with the extra small, small, medium, and large, extra large, and so far. At the last, we have maximum of 5x large and 6x large, but there is a limitation that 5x large and 6x large is available into the preview future. That is only currently available for the Azure Amazon Web Services, not for the other cloud services. So based on the virtual warehouses sizes that we select, the credit or the costing has been depend when we create the virtual warehouse. So the default virtual warehouse size is allocated as extra small. As per our requirement, we can manipulate it, we can enhance the virtual warehouse sizes depend on our query load and the data load. The one credit will be consumed by 1 hour in the Snowflake for the extra small. Likewise, for the small, 2 credit will be consumed for 1 hour. For medium, 4 credit will be consumed for 1 hour. The calculation and the credit management is all depend on the virtual warehouse size that we select. But the limitation of the virtual warehouse sizes is when you have a multiple queries that is to be parallelly execute, but based on the compute resources or the compute nodes that are available into the virtual warehouses, that has been if particular one query that is consumed all the resources that are available into the one virtual warehouse, then second query will be in a queue. It will wait to complete or the finish the first query execution, and that then only it will start execution of the second query. So to overcome that problem or the challenge, we have a multi-clustering warehouse concept provided by the Snowflake. So this multi-clustering warehouse comes in a picture when if sufficient resources are not available to execute all the queries submitted to the warehouse, the Snowflake will queue that additional queries until the necessary resources become available. We need not to do additional setting for the multi-clustering warehouses. Rather, while creating the warehouses, we have to specify the maximum cluster and the minimum cluster count. So based on that count, uh, the multi-clustering behavior will change. Basically, there are two types of behavior of the multi-clustering warehouse. One is maximized and second is auto scale. So basically, maximized means that whenever the query starts execution, the Snowflake will start all the warehouses that has been mentioned into the maximum warehouse and minimum warehouse. So basically, for example, if we specify two minimum and two maximum warehouses, so whenever you execute any query, it will start those two warehouses and it will take that query and execute the query. And second part is auto scale that can be implemented by specifying the different value in the maximum resources and minimum resources. So this auto scale and maximized, which I can explain you by using the one example, that is for the credit usage. So first you can see that in a first table you can see that we mentioned the three warehouses as a multi-clustering warehouse. So our if I start to any query, so that query took the 1 hour. If in the first hour, the Snowflake will start all the warehouses like warehouse 1, warehouse 2, and warehouse 3. So it will consume the 4 credit. On the second hour, again the query started execution and continues to execution. So again, on for the second hour, it will take consume 4 credit. So it's become a total 12 and 12. So total 24 credits will be consumed to execute the 2 hours of a query execution if we select the maximized multi-clustering warehouse. Whereas the in auto scale, in the first hour, Snowflake started the warehouse first based on the requirement. Warehouse 1 started, so it will consume 4 credits. But in the first hour, the warehouse 2 and warehouse 3 has not started, so it will consume 0 credit. But for the second hour, if our query consumes the warehouse 1, warehouse 2, and the warehouse 3 for an half an hour, so total credits will be consumed by Snowflake will 4 plus 10, 14. So that is the difference between maximized and the auto scale multi-clustering warehouse. So let me uh, explain you better way in a while giving the demo session. So like here you can see I have created one warehouse, compute WH warehouse, which is currently suspended, and the size of the warehouse is extra small, and minimum and maximum I have set up as a 1, and the scaling policy is the standard. So if I go and configure here, configure setting, I can choose any any warehouse size up to 4x, because 5x and 6x are available into the Amazon Web Services, and it is in preview mode only. So if I choose the small, it will consume 2 credits per hour. The maximum cluster, minimum cluster that I can choose, and based on this option, you can set up the multi-clustering option. You can enable that. The one thing that I wanted to highlight here is the multi-clustering will be enabled for the enterprise edition of the Snowflake. The standard edition will not allow to create a multi-clustering feature. So my account is enterprise as the business critical edition. So I can enable the multi-clustering. So if I choose the 2 maximum cluster, and minimum cluster will be 1 or 2, you can see. So if I select the 1, there is a different values in the maximum cluster and minimum cluster. So it will create the auto scale multi-clustering. If I choose the 2, then it will actually work as a maximized multi-clustering things. Scaling policy I can show you in a different lecture. Auto suspension is the option that the Snowflake has provided. So if the Snowflake warehouse is not running for some particular time of a period, let's say if I can select that 5 minutes or 10 minutes. If my warehouse is not running for 10 minutes, then automatically this warehouse will get suspended. Auto resume is the option that we have. By default, auto resume is enabled. So auto resume is that when you start the query execution, the auto resume will enables that the warehouse, else it will remain as a suspended in the Snowflake. So that is the option. So here is the configuration of warehouse. Once you configure all everything, then you can simply select a finish, click on finish, and then you are done. I hope you understand and enjoy this lecture. We'll see you in our next lecture then. Thank you.